Okay, we'll start this numerical now. It says a solid shaft has to transmit what? Is it power or torque? So 192 kilowatt is not torque. Some people may actually directly substitute this as torque. Please be careful. This is not torque. What they are given is power. They have said the solid shaft is to transmit 192 kilowatts. Sorry, 192 kilowatts of power at 450 RPM. At 450 RPM. And this shaft material has got the allowable shear stress, which is actually of 70 MPa. You know that shear stress is usually half of the maximum normal stress. I think you have seen this in Mohr circle, no? Okay, suppose you've seen this in Mohr circle. This is, suppose if this is actually 250, then we say that this is 125. So usually, if you try to stretch a body, suppose if you fix a body and apply force here, and if you apply a force of 250, it fails. If you apply a force, suppose if you apply a stress, sorry, I'm using wrong words. If you apply a stress of 250 Newton per mm square, it fails. And similarly, and it could also fail by shear. It could also fail by shear at an angle of 45 degree, because this is how much? 90 degree here. It is 90 degree. At an angle of 45 degree, this is 90 degree here. You will have the maximum shear stress. This can actually fail by shear like this. It can actually fail by shear. Okay? So that is shear. So usually shear stresses, the failure values of shear stresses are lower when compared to the normal stresses. Okay? You have to keep this in mind. Okay? So this is, okay, this problem it is given as 70 MPa. Maybe they have taken some factor of safety. Maybe suppose if this is 140, they have taken factor of safety as 2. Suppose if the maximum normal stress it can take is 280, the maximum shear stress it can take is 240. So they have actually limited it to 70. Now this term tau allowable. Allowable means how much you can allow. People also can call it as design stress. Tau design. Okay. So that means you are only limiting it to this. So that is equal to 70 MPa. You know that 1 MPa is nothing but 1 Newton per meter square. I will explain you later. Now there is no time. 70 Newton per meter square it is. Okay. 70 Newton per meter square or millimeter square? Guys, this is wrong. Here, this is actually 70 into 10 to the power of 6. Pascal is 1 Newton per meter square. So, 70 into 10 to the power of 6, Newton per meter square. So, meter square is actually 10,000, 10 to the power of 3 millimeter square. So, this 10 to the power of 6, 10 to the power of 6 cancels out. So, 70 MPa is nothing but 70 Newton per millimeter square. Okay. So this is 3 square. This is 3 square, 70 Newton per mm square. So please, you can actually go along in many ways. One is don't take this directly as torque, this is power. And to take this value of 70 MPa as 70 Newton per mm square. Okay, and with this, I think with this too, you can start the problem. Before you start the problem, you should convert this as actually torque. So we use an equation which is very familiar to us, which is actually given by the equation 2 pi is equal to P is equal to 2 pi nt by 60. If you want it in kilowatts, again divide by 1000. Okay, this is the equation that everybody has seen. So here they are given power. Here they are given power. So power is actually 192 kilowatts. It is kilo. Again, people don't seriously look into every value here. It is kilo 10 to the power of 3. Watt is actually 1 Newton meter per second. So 1 joule is Newton meter, joule per second is watt. So here watt is 1 Newton meter per second. Newton meter is joule. Work done in trying to move something by using 1 Newton of force over 1 meter is 1 joule. If 1 joule of work is done in 1 second, it is power. That is 1 watt. If 1 joule is done in 1 second, it's power. That's 1 watt. So this is watt can be written as Newton meter per second. Okay. Again, if you don't want this Newton meter per second, then you can actually write this as 192 into 10 to the power of 6. You can convert this into millimeter. You can convert this into 10 to the power of 3 millimeter. Then it becomes 192 into 10 to the power of 6 Newton millimeter per second. Because here you have taken millimeter, here if you again take meter, then no matching of units. So you have done this. So you have already done two things here. One, converted this value, and again converted this power into Newton millimeter per second. So let us now substitute this now. So 192 into 10 to the power of 6 Newton millimeter per second is equal to 2 into pi. Pi is 3.14. N is how much? 450 RPM, rounds per minute. So since it is per minute, you want this per second. On the left hand side, what you have is per second. So you are dividing it by 60. If in the numerical, if it was given 15 RPS, then you don't have to divide it by 60 because it is already per second. Okay, now it is in RPM, rounds per minute. You want to convert that per second, you are dividing it by 60. Okay, multiplied by T. Here you know everything, you don't know T. Please find out the value of T. Anybody can find this value of T? And what will be the unit of T? Can you guess here? So here, guys, you can look at these values here. These are constants. These are constants. These are constants. This is RPM, rounds per minute. So again, it's rounds, no issues. So if you want to balance the unit, this is seconds. Now to balance the unit, you have to have Newton millimeter here. Newton millimeter per second, Newton millimeter per second. So this torque unit has to be Newton millimeter. Okay, don't ask somebody what is this torque unit here. So you are trying to balance the units. So whatever the answer is that you get for this torque will be T Newton millimeter. Okay, use your calculator to find out this.
40 lakh 76,000.
40
76,433.
433.
0.12.
Okay, that seems to be a very huge torque. So you can actually make this easier by writing it as 4076.43 into 10 to the power of. So you can make this as 10 to the power of 3 Newton millimeter. Or so I think you can leave it here. It's okay. No issues. No need to again confuse this because I think this is not required. Because again we may have to find this here. Okay, and then we know once you have found out this, guys, once you have found out this, guys, can somebody remember this formula for torsion?
T by GT.
Okay, T by GT. Okay, adu nimge ಹೇಳ್ಕೊಟ್ಟಿದ್ದೇನಲ್ಲ ತೀರಾ ಜಲ್ದಿ. Okay, here most of the times this part of the equation is used. Hardly this part of the equation is used. Okay. So now here what and all is given in the problem?
T, tau,
So you have found out T.
tau,
You have found out. So the tau was already given. What you don't know is JP. Okay. So JP value you have to find out. So what is actually JP for circular shafts? What is JP for circular shafts? Pi d to the power of 4 divided by 32. And what is R? What is R in terms of D? It is D by 2. Okay. So you can substitute this now here. So suppose now if you try to replay with this equations, T by tau is equal to JP by R. JP by R. JP by R. So JP is pi d to the power of 4 divided by 32. And again this is D by 2. D by 2. So what will happen? This becomes pi d to the power of, pi d cube. And this goes above. Will it become 64 or?
so 2 by D.
So this becomes 16 because this 2 goes here to the numerator. It goes to the numerator. Now this equation becomes like this: pi to the power of 32 divided by 2 divided by multiplied by 2 divided by d. So this becomes 16. This becomes cube. So you can say that JP by R is pi d cube by 16. So this is called as polar modulus. JP by R is called as a polar modulus. So you can remember this directly. And you need to and now you just need to substitute. Everything is substitution. There is not much things to remember. So here the value of T was given. So T is 4076433.12. That is, now this value is already there in a calculator. Divide by tau. So divide by tau. So tau is how much? 17 Newton per mm square. Okay. This T is Newton millimeter. And this pi d cube by 16. So pi into d cube. D is not known to you. This is 16. So here, what is left? So you just need this value. So send these values to the other side. 4076433.12 into 16 divided by 73.14 is d cube. So what is this value, man? Can somebody say what is this value?
296587.
296587. 0.1914. Okay. So when you actually try to cube root of this, when you try to do the cube root of this, d is equal to how much? 66.66 68 mm. Guys, in your scale, how much is actually 66 mm? 66 mm is this big shaft. I mean this shaft of this diameter. They need a shaft of this diameter to transmit so much amount of torque. I think you have seen in SUVs, no? This propeller shaft going to the rear axle. Most of the SUVs are rear wheel drive except XUV 700. XUV 700 is a front wheel drive vehicle. Okay, all wheel drive. Okay, now it's all wheel drive. Suppose if it is actually rear wheel drive, then you see the propeller shaft, no? So propeller shaft will have this much diameter. Now this much diameter is actually around 6 centimeter, which is actually 60 mm. You found out there is some meaning. All these equations are not for troubling you. This is for aiding you to design shafts where you need to transmit so much of power. Okay. So you have found out D is equal to 66.68 mm. This is one of the problem. Okay. Any issues?